Hello children, this is Ashani Dashgupta from Cheenta. Today we will be talking about geometric transformations. This is the second episode of this series, so if you have not seen the first one, I encourage you to go and check it out. But you can still follow the second one if you're just starting from here. Geometric transformations are very important for mathematical Olympiads. They are also quite important for ISI-CMI entrances. Most important thing is this. They are actually very beautiful. When you are able to use them and solve geometry problems, you feel really happy about it. And that's, I think, the most important reason I do geometry transformations. In the first episode, we learned something about it. We actually did a problem on rotation. So if you do not know what is geometric transformation, I'll give you right away some examples. Rotation is an example. Translation is an example. Translation means you shift along a certain direction. Reflection is another example. And then in the last video, I actually talked about two more examples which are a little bit different, inversion and homothety. We will come to that as we go through these topics. But for today, we will continue to focus on rotation. Because there is a lot you can do just using rotation. And I will give you a challenge problem as we go through this video. And we will talk about a very famous treasure island problem. So this is a beautiful application of geometric transformation, especially rotation. And if you know how to use complex numbers in geometry, then you can get an even better entertainment out of this problem. So I'll tell you the problem first, okay? So the problem is like this, that there was a pirate who went to an island. So let's draw this island like a square box. But of course, the island may not be square. He goes to this island and he deposits some treasure. He buries it underground so that no one else can find it. So he goes to the island, buries the treasure, and then makes a map. So what is the map? The map is like this, that there is a well in the island and there are two trees. So let's say tree 1 and tree 2. So the map is like this, that you start at the well, you go to tree 1, you turn 90 degrees, so like this, and you have to make sure that these two distances are same. So well to tree 1 and tree 1 to however distance you go, these two distances must be the same. So you go, turn 90 degree and place a flag down there. Let's call it flag 1. The same thing is true. You come back to the well, you go from the well to tree 2, turn 90 degree and place another flag. Again, you move through the same distance. So well to tree 2 and tree 2 to flag 2, the distances are same. So what he does is, he puts the treasure in the midpoint of flag 1 and flag 2. This point M is the treasure point. Okay? So if you did not understand the instructions, I would encourage you to just go back and sort of revisit the instruction, because soon we will start finding the treasure. Okay, so what happened is that the pirate buried the treasure and he went back to his hometown. And now he's old, 10s and 20s, several years have passed, and he's old and he wants to get the treasure back for his children. So he explains the process to his son. He tells him that, okay, you go to that island, you will see there is a well and there are 2 trees. So you start from the well, you go to the tree 1, turn 90 degrees, then walk the same distance and place a flag. Come back to the well, go to tree 2, turn 90 degrees, place the flag after walking the same distance. And the treasure will be in the midpoint of the 2 flags. So his son is very happy. Of course, he's getting the treasure. So he goes to that island. He sees that the trees are there, but something has happened and there is no sign of a well. There is no well in the island. So maybe there is an earthquake or something has happened. The well is not there. So what should he do? Should he come back? Because his starting point was the well. There is no well anymore in the island. The trees are there. So then what the pirate's son did, well, he actually attended some Math Olympiad classes, I guess. So he actually did some transformation geometry and applied a little bit of complex number in geometry, and he found a solution to find the treasure. So what is the solution? Well, the solution is kind of like this. Let's go ahead and draw the picture a little bit more clearly. So of course the tree 1 is here. Let's mark it as a point, tree 1, and the tree 2 is here. Let's mark that as a point as well. There are 2 trees in the island. It's a completely barren island. Only 2 trees are there, but there is no well. So what the kid, son of the pirate, what he did is he just went ahead and marked a random point as W, well. In fact, he wanted to experiment a little bit. So he marked it as W1, one possible position of the well among hundreds and thousands of possible positions, right? So from the well, he then goes to T1, turns 90 degrees toward the other well, walks exactly the same amount. So these 2 are same equal amounts. And then he places the flag 1 here. And then he comes back to well 1, does the same thing. He goes to T2, draws this thing, these 2 are exactly equal, and then he marks this one as F2. And then he joins F1 and F2, and of course M is the midpoint, M1. So if the well was here, that's a very big if. There are infinitely many positions of the well. If the well is here, then M1 is the position of the treasure. But the guy is actually very clever. So what he does is he actually tests out with another position of the well. He says, okay, what if the well is here? So let's check this. And this is why I stress this to all the students at Cheenta and all of you who are viewing this YouTube channel. Experiment with mathematical formulas and ideas and questions. Just experiment, you'll see patterns emerging. So what he does is he started from well 2, went to T2, turned 90 degrees and went here. So let's call this let's call this P1. And then from W2, he went to T2, turned 90 degrees and went to P2. Now something very interesting happens. The midpoint of P1 and P2 turns out to be the same point as before. This is really weird. We started from W1, which is an arbitrary position for the well. We followed the instruction of the pirate, we found a midpoint of the two flags. And then we randomly chose another point as the well. We did exactly what the pirate told us. And this time when we found the midpoint of the two new flag positions, that's the same as the previous midpoint of the previous two flag positions. This is completely insane. And that is the beauty of it. What the pirate's son just found is that the position of the treasure is independent of the position of the well. Position of the treasure is independent of the position of the well. How can you prove this? Well, you can actually prove this using rotation. And what we'll do is, we'll do a little bit of transformation using complex numbers. Nothing very hard. You will be able to understand part of it even if you don't know complex numbers. You have to take some portion of it as a fact, because I'm not going to teach entirety of complex numbers in geometry here. But I'll give you some hints. You can still follow along if you don't know complex numbers. So here is an application of complex numbers and rotation. So the only thing you have to know is that if you want to rotate something by 90 degrees, if you want to rotate something by 90 degrees, then you have to multiply it with I. Rotate by 90 degrees counterclockwise. Then you have to is same as multiply by I, the complex number I. So how can you multiply? Well, you can think of each point on the plane as a complex number, and then you can multiply it by I. So I'll give you an example. If you have a point 1 plus 2i, this point here is 1 plus 2i, right? So you can take, this is the origin, this is the point P, OP. P is 1 plus 2i. That's the position of the point P. Now, if you multiply P with I, you get 1 plus 2i times I, which is I minus 2. Y minus 2, because I times I becomes negative 1, right? I into 1 is I, and 2i times I is negative 1 times 2, which is negative 2. So that this is simply minus 2 plus I. So what is minus 2 plus I? Minus 1 minus 2 I. Okay. So this point here is minus 2 plus I. This is Q. And see, the angle between POQ, at least I think you can check it from, like visually check it, it's 90 degree, this angle. That is what I'm saying. When I say multiply by I when you want to rotate by 90 degree, then that's what I mean. Now, there is a very beautiful theory behind it, why this happens. And if you are already a student at Cheenta, then of course you are seeing this in the complex numbers and geometry module. And if you're not, then maybe we can discuss something like this later in our YouTube channel as well. Okay. All right. So coming back to it, so you multiply by I. So what you do is, well, you have to think of the island. So this is the island. And the position of the tree 1 is T1. It's some complex number. So T1 is some A plus A1 plus IB1. And there is T2, which is A2 plus IB2. So what are we doing? Okay, let's take an arbitrary position of the well, W. So W is equals to, let's say, X plus IY. Some position. We don't know what is the position of W. Okay. So what we are going to do is we want to rotate WT1. We want to rotate WT1 about T1 by 90 degree. This is very important. We want to rotate WT1 about T1 by 90 degree. So what is WT1? Well, WT1 is, so you want to bring T1 to the origin in some sense. So W minus T1 times I. That's what it is. You want to rotate WT1 about T1. So what you do is, wherever the origin is, you subtract from T1. So this is T1 minus T1, which is 0. So you're basically bringing it to the origin, and similarly you subtract W by T1 from W. So this point is W minus T1. So now you have this particular segment placed at the origin. Now you can rotate by I, which is 90 degree. So W minus T1. So now it is here. It's here rotated now. This is W minus T1 times I. And then you can push it back to T1, because ultimately you want it here, right? So you add T1. So you add T1 back. So this point is W minus T1 times I plus T1. Similarly, you can do the same thing here. You want to rotate WT2 about T2 by 90 degree, but this time clockwise. So what do? Well, you do W minus T2 times minus I, because clockwise rotation, minus I plus T2. You go back to the origin, you rotate, you go back to T2. Okay? All right. So now this point is here. So W minus T2 times minus I plus T2. So what do you do now? Well, you want to find the midpoint of these 2 points. What do you do to find midpoint? You add and divide by 2. So that's what we do. So W minus T1 times I plus T1 plus W minus T2 times minus I plus T2 divided by 2. So if you just expand it, it is Wi minus T1I plus T1 plus minus Wi plus T2I plus T2 by 2. So Wi minus Wi cancels. So whatever is left out, I think you can see it. It is T1 plus T2 minus I times T1 minus T2 by 2. This is the position of the flag M, of the treasure. So the great thing about it is it does not contain W, which means this point is independent of what W you chose at the very beginning of the process. So how beautifully rotation, complex numbers, geometry, everything is falling into place, right? I hope you enjoyed and learned something from this video. I'll see you in the next one, and we will learn some more transformation geometry. And if you are planning for Mathematical Olympiads, ISI-CMI Entrances, Physics Olympiad, Computer Science Olympiad, I'm sure that in Cheenta you will find some outstanding friends, teachers, with whom you can together learn these subjects. We are very passionate about problem solving. Check the link in the description for more details. Thank you for joining in today. I'll see you next time. Bye.